In engineering, a drawing is a precise language that bridges the designer's vision and the builder's hands. It must be clear, unambiguous, and complete, especially when it comes to assembly sequence. The assembly sequence is the step-by-step story that transforms individual parts into a working whole. Without it, even perfectly made parts are just an unsolvable puzzle. Imagine receiving a box of parts for a new machine. Without a guide, assembly would be nearly impossible. The assembly sequence on a technical drawing answers: what comes first? How do parts fit together? What's the right order? This roadmap prevents errors, saves time, and ensures the final product meets its specifications. Detailing assembly sequence has evolved from simple notes to sophisticated global standards, enabling international collaboration. These conventions ensure a drawing made in one country can be built anywhere in the world. In this guide, we'll explore the principles and methods for indicating assembly sequences in mechanical drawings. We'll cover techniques from ballooning to stage tables and sectional views. You'll learn best practices for both creating and interpreting these instructions. Mastering these concepts will help you communicate designs clearly and build with confidence and precision. Let's turn the silent language of drawings into real, working products. An assembly sequence is the logical order in which parts are put together to form a complete assembly. It's a carefully planned set of instructions designed for efficiency, safety, and accuracy. The sequence considers accessibility, tool requirements, and the physical constraints of each component. For example, a bearing must be pressed into a housing before inserting the shaft. Reversing the order could cause damage. The assembly sequence captures this critical knowledge, ensuring the product functions as intended. The level of detail varies. Simple products may need only an exploded view, while complex assemblies require detailed subassembly instructions. Each subassembly has its own steps, all integrated into a master plan. Deviating from the prescribed sequence can cause parts not to fit, damage, or even catastrophic failure in safety-critical products. Treat the assembly sequence with the same importance as any dimension or tolerance. It's a core part of the product specification. A clear assembly sequence minimizes errors and eliminates guesswork on the factory floor. Without it, technicians might damage parts, waste materials, or delay production. A documented sequence ensures every unit is built the same way, supporting quality control. It's also a powerful training tool. New technicians can learn the process quickly from the drawing, not just from experienced workers. This documentation preserves knowledge and streamlines communication between departments. Safety is built in. The sequence can specify when to install heavy parts, perform checks, or use protective equipment. For example, sealing and leak testing a vessel before installing electronics reduces risk. Economically, a well-planned sequence boosts efficiency, reduces labor costs, and minimizes handling. In today's competitive industry, these efficiencies are crucial. The assembly sequence is more than instructions. It's a driver of quality, safety, and profitability. It's essential for manufacturing success. The most basic way to show assembly sequence is with balloon numbers on an exploded view. Each part gets a unique number in a circle, linked to the part on the drawing and the bill of materials. The assembly follows the order of the balloon numbers. Part 1 first, then 2, and so on. This method is intuitive and ideal for simple assemblies, like a flange coupling. For example, flanges, bolts, washers, and nuts are numbered in order. The technician just follows the sequence. Balloon numbering keeps things clear and uncluttered for straightforward builds. However, with complex products, too many balloons can make the drawing chaotic. Ballooning doesn't easily show simultaneous actions or special steps like applying adhesive. For complex assemblies, ballooning is often combined with more detailed methods. It's a foundation, but not always enough on its own. For complex assemblies, engineers use assembly stage tables to break the process into clear steps. Each stage lists the operation, the parts involved, and references balloon numbers. For example, Stage 1. Press bearings into the engine block. Stage 2. Apply lube and install crankshaft. This method combines visual and textual instructions, leaving little room for error. Stage tables can include details like torque values, adhesive types, or inspection steps. They formalize the process, supporting quality control and troubleshooting. If issues arise, the table provides a record of the exact procedure. Stage tables turn a drawing into a comprehensive manufacturing document. Visual tools like exploded and sectional views are essential for understanding assemblies. Exploded views show parts separated along an axis, clarifying how they fit together and in what order. Center lines guide the eye and show alignment. Sectional views cut through the assembly to reveal internal details, crucial for showing how seals, bearings, or gears are positioned. These views often highlight critical steps in the sequence. Combining exploded and sectional views creates a complete visual narrative. For tricky steps, detail views zoom in on specific areas, like seal installation. These visuals help not just technicians, but also designers, service teams, and customers. A well-done view clarifies complex mechanisms and aids troubleshooting. They bridge the gap between technical data and real-world understanding. Let's see these principles in action with a simple gearbox assembly. The drawing features an exploded isometric view, with each part assigned a balloon number linked to the bill of materials. The assembly sequence is detailed in a stage table. Stage 1. Press oil seals into the housing, with a detail view showing correct orientation. Stage 2. Install bearings onto input and output shafts. Stage 3. Insert shaft sub-assemblies into the housing, ensuring proper gear mesh, confirmed by a sectional view. Final stages. Apply sealant to the cover, assemble with bolts, and torque to specification. Each step is visually and textually reinforced, preventing common errors. This multifaceted guide ensures the gearbox is assembled right the first time. The result, a reliable, high-quality product. Clarity is key when creating assembly drawings. Start with a logical assembly plan and use a consistent balloon numbering system. Keep views uncluttered. Break complex assemblies into sub-assemblies if needed. Use a mix of view types, isometric, exploded, sectional, and detail views to clarify each step. Add notes and tables for information that can't be shown visually, like torque specs or inspection points. Always have someone unfamiliar with the design review the drawing for clarity. For technicians, review the entire drawing set before starting. Check the exploded view, read all stage tables, and verify parts against the bill of materials. Never skip steps or change the order. Each sequence is designed for a reason. Pay attention to notes on torque, lubricants, and sealants. Use all provided views to confirm part orientation and placement. A disciplined approach ensures quality and professionalism. A well-defined assembly sequence is the backbone of manufacturing. It translates design into reality, using balloon numbering, stage tables, and sectional views as a universal language. This clarity eliminates ambiguity, reduces errors, and ensures every product is built to the highest standard. The benefits: faster assembly, lower costs, better quality, and improved safety. It also serves as permanent documentation for training and troubleshooting. Real-world examples, like the gearbox, show how these methods work together. The synergy of visual and textual instructions empowers technicians to build complex products with confidence. A clear sequence transforms assembly from a source of error into a repeatable, controlled process. It's a testament to thorough engineering and respect for the technician's craft. Ultimately, the assembly sequence binds design to production, ensuring every product can be built right every time.